Good morning, biology students, both honors and fifth and sixth period biology. Today I'm going to quickly just run through and highlight some of the main points for the notes that were issued yesterday. Those notes you should continue to work on today, Wednesday, September 9th, and hope to conclude and submit by the end of today. If not, you will start to fall behind as you get work based off these notes on Thursday and Friday. So we are now moving into chapters 2 and 3 from the book, and I went ahead and in your stream I added chapters 2 and 3. So that's where you can reference these notes. These notes do not come directly from the books, but they include information from chapter 2, and then we'll move into chapter 3, which will be macromolecules and the importance of carbon. So really, if you've started to look at the notes, some of the topics we're going to look at is what makes up or what constitutes matter, and then we wind up getting into the periodic table, which is made up of, well, currently we have 118 elements. Then we're going to start to look at the composition of matter. So at the smallest unit we'll look at will be what makes up the atom, and then we'll look at a little bit with water and it being a polar molecule. And then at the end of these notes, we'll look at the pH scale. And then as we continue on into next week and possibly the week after, we'll look at the importance of carbon and macro. So that would be macro molecules. I did reference this early on before you left. So we're talking about things like carbohydrates, proteins, lipids, which really just means the type of fats we eat, and then the last one would be nucleic acids, and those would be your DNA and RNA. So really what you want to do is, as you make your way through the PowerPoint, you should be looking on your note sheet and seeing what it's asking you to do. So the first two things they're asking you is to define matter and elements. So again, you're really looking at the information from the PowerPoint and then filling out your note sheet accordingly. The periodic table. So again, we currently now have 118 named elements on the periodic table. And there are some elements that are very important to biology. You might be wondering, well, why are we looking at the periodic table, which is mainly a chemistry construct? But again, there's a lot of elements here that are important to life. And again, you have a chart, and you're going to be looking at 6 right here. So again, you've got carbon, oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. One that's not here, which fits nicely into a little acronym, is something called CHINOPS, and that would be your carbon, your hydrogen, nitrogen, oxygen, phosphorus. And I know they're listing calcium here, but from what I learned too is also sulfur is important. So again, this will help you remember these. And again, all organic life on this planet is based on carbon. We know the importance of oxygen, hydrogen, nitrogen, calcium, and phosphorus. So even though I do mention sulfur, this note sheet went with phosphorus. And again, you want to list out the name of the element, its symbol. This would be the percent of your body weight. And then what is the significance? So you want to fill out your chart there. And you got some examples of why they are important. And then we're going to get to the building blocks of matter, which are atoms, and going through the three main parts, which are your protons, your neutrons, and then your electrons. And each one of those, the neutrons carry no charge, and the protons and electrons carry their own specific charges. So again, going through, filling out your notes here, and then distinguishing between what is in the nucleus, which would be the center part of an atom, and then what is on the outside. So again, the nucleus is going to have your protons and your neutrons, and then you're going to find all your electrons out in what they call the electron cloud. So again, making your way through atomic number and atomic mass. So we're going to have an assignment coming up that has us work with what these boxes on the periodic table can tell us, and they can actually tell us a lot. So I'll let you fill your notes through, and then we'll work with those on an assignment coming up later in the week. Ions. So ions, again, are going to be atoms that either gain or lose electrons. Remember, electrons are going to be the part of the atom that interacts with other atoms. So if you're gaining or losing electrons, you now become an ion, and you can have positive or negative ions. And a lot of these are important to biological systems, including our own body. A couple of slides on bonds. So again, we're not going to be working too much, but we want to know, again, some of this terminology. So I would pay attention to, again, the bolded words and looking at their definition. And again, these are these valence electrons. The big thing here is to realize these are your outer electrons. These are going to be the ones that interact with other atoms. So here you have a couple of electrons in this inner shell. They're not going to be reactive. The only reactive electrons are going to be the ones in the outer shell. All right, so we continue to going through working with these different bonds. You can have single, double, or triple bonds. And again, that's one thing that makes carbon so unique, is it can make these different bonds, right? You can have carbon connect with 4 other things, or if you have a double bond, if it's double bonded, then it can connect with 2 other things, and then carbon can even have a triple bond. The big thing with carbon right now, even though we're not going to get into it until our next note packet, is carbon can make 4 bonds, and that's going to be a big reason why it's so important to biological systems. All right, so continuing on and finishing with the atoms, and then looking at properties of water, like why is water so important? And we did hit on this before you guys left, that again, water, you can only go a couple of days without water. You can go a little bit longer without food, and that just goes to the importance of water for all life. A couple of properties are going to be cohesion and adhesion, so you're going to want to distinguish between those 2 terms with water. And then some of the properties, again, why is it so important? It has a high heat capacity, universal solvent. And then the last thing you're going to look at on the notes is acids and bases and the pH scale. So how do we differentiate between acids and bases. While we look at a pH scale, it really just means the power of hydrogen. So you're looking at the amount of hydrogen that's in a solution. And here you've got a great visual for the pH scale. So if something is neutral, like pure water, it's going to be right there in the middle at 7. And then something that's extremely acidic and can actually harm you would be something that has a pH down at 1. One thing to note is that this is a logarithmic scale, so you might think, well, going from 1 to 2 is not a big deal. But when you go from 1.1 to, or 1 to 1.1, right, you're actually talking about, it's a power of 10. So you're actually increasing it by 10. So that's something to keep in mind. So even small differences could make a big difference in you becoming harmed or not. So you make your way up. So again, these are all things that are acidic, and then now we call these basic or alkaline. So you're looking at a lot of cleaners over here are considered basic, and then you can see some of the more representative examples of acids. Right, so, and again, there's just some information on acids and bases. All right, that's it. If you have any questions, I will schedule a Google Meet for today at 12:30 for anyone to log in and ask any questions you have as you finish the notes. It will be important for your assignments coming up on Thursday and Friday. Thank you and have a good day.